In this video, we are actually going to look at the layout of the ACC project, how the things are connected, how everything is going to work together, how to launch the project, etc. So this is the basic ROS graph that has been generated from our project. So what has been done to the original project? The original project had an A1 and an A2, and what we did on our side is basically to interpret. So what was happening was the A1, there was this target path which was going to this node called the path following. So the path following was initially sending the command velocity which went to the twist control, which basically created a steering and a throttle command and a brake command. So that was the initial implementation. So that if we can look at it here, I mean, over here also I made some modifications so that I can control the speed of the vehicle in the front, but initially that was the implementation. The path following was going directly to the via this thing to the twist node. So in our project, the thing that we actually did was is the introduction of the speed limiter node. Okay, so the speed limiter node's job is to limit the speed that was actually provided. So the path following basically provided the speed. So the speed limiter basically was what we need to do. What it did was we redirected the speed through the speed limiter node. So the speed limiter basically takes the speed, then it also gets the current speed from the twist A1 underscore twist message. So it gets what is the required speed with what is the current speed, and it also understands other things. Okay, and everything else that we actually added was inside this ACC group. So we just decided to put inside the ACC group. So the only output that is actually coming out of here is basically the distance to the car in the front. So basically the output of everything that is inside here is basically the distance to the car in the front. So that's what the ACC distance to the car in the front. So basically using the distance to the car in the front, what is the required velocity, what is the current speed, the ACC speed limiter either decides to reduce the speed or just allow the speed to continue how it is. So this is the thing that we added in between so that we can control the speed of the vehicle vehicle behind the red vehicle. And the other set of nodes that we actually added are essentially what is inside the ACC. So inside ACC, what we have is essentially the net output is the net result of this thing is what is the distance to the car in the front. The distance of the car in the front is actually provided by a component called the fusion module. The fusion module basically accepts. So we have three sources of input. We have the camera that's providing a distance to the car in the front. Then there is a lidar that's actually providing the distance to the car in the front, and then there is the GPS which is also providing the distance to the car in the front. Okay, so the fusion module's job is basically to combine all three of them and then basically create a fused output to the distance in the car in the front. And that's the primary job of this. Okay, initially we created that maybe we can also do the speed, but we in the end we didn't estimate the speed of the car in the front. So all these three nodes, the three sensors basically provides their respective version of the distance to the car in the front, and the fusion basically combines it and provides us as an output which is basically fed back to the speed limiter to limit the speed. And that's entirely our design of how things are working. Other than that, the whole thing is what is originally provided. Okay, in here we also had in the A2 model, which is the blue car in the front, what we did was we actually added another node. So we actually added a node called the P front car control. Essentially this is to so reduce the speed of the front car. For the demo purpose we wanted to control the speed of the front car. So this is just, so initially it was going from path following via like this. So we added this extra node in between so that we can actually control the speed of the car in the front and see what happens if you are in an ACC mode and suddenly the car in the front comes to a stop. How does the system behave? So that's essentially our ROS graph related output. The output of the speed limiter is again a command velocity, which basically goes to a twist control, which generates the speed and the throttle and the brake, just like initially it was how it was in the given project. Okay, as far as launching this project, just at a level of the source code, I just want to give you a brief read of this is a folder structure, which is the ROS final project, which essentially has all the components that I've shown as separate folders. So the ACC speed limiter it contains all the source code related to ACC speed limiter. Cam location, basically all the code related to camera control. This is all the things related to the front car control. This is all the things related to the GPS based location. This is everything related to LiDAR related location, and obviously this is related to the fusion, all the codes that are related to the fusion, and each one of them are separate nodes within the system. Okay, and in order to control all of them and to launch all of them, so what we had to have one central place, and our launch files are actually located in ACC speed limiter. Like if you go to ACC speed limiter, inside here we have a launch folder, and inside the launch folder we have actually all the launch files. And specifically with respect to the launch files, we have one launch file which if you launch this one, it will launch with all the nodes. That means the GPS, the LiDAR and the radar, and the camera, and then we will see what is the output. So if you launch this one, this will just launch only the speed limiter and the this is the camera only one. This is the only one with GPS as the only sensor. This is with LiDAR and camera and no GPS. Like this is the one that would realistically represent a real world scenario where you definitely don't know the GPS coordinates of the other car. You only have real world sensors like a LiDAR or a camera, and this is the one that is just with the LiDAR. So the reason we wanted to have multiple launch files is to understand how a sensor by itself, how does it perform, like LiDAR, GPS and camera by itself, and whether in a real world scenario, whether the LiDAR and camera together, how does it work, and if all three are available, then how. This is just a theoretical thing. How does it work? So these are our launch files, and this is our folder structure. In this video, we are planning to see a demo of our project, what it does. So for this particular part, we are going to launch the speed limiter with the GPS. Let's just run with the GPS, with all GPS. So once we launch this project, the base scenario should be applicable, which is camera perspective, FPS. So right now this other car is actually accelerating, and it reached the car behind, and it's actually following the car in the front at a safe distance. And if you can look at it, so over here, right, what it's printing out to the ROS info, it comes out from our fusion module, basically is the distance to the car in the front, as said by the GPS, as indicated by the GPS. Let me just so this is the distance to the car in the front as per the GPS, the camera, and the LiDAR, and what is the fused value. So you can see that there are three sets of values that are provided by each one of them, and they are roughly the same. And the fused speed is what the car in the this guy is going to use to determine what to do about the scenario. So right now this car is actually safely following the other car in the front, and that represents our base case. In this video, we are actually going to see some of the controls of the that is allowed by our project. So I'm going to launch all the cars in the thing, and in order to control the various parameters, we need to do then launch the RQT, camera perspective. So this car is actually following the car in the front, and in this video we are going to see what we're going to happen if we allow to control the speed of the car. So this parameter control is the override. So we have this P front car control, right? If this is the speed of the car in the front, so I just change the speed of the car in the front to 0, and as you can see, right, our car just came to a stop at roughly the same 12 meters per before that particular car. And now what I can do is I can put this thing, and I can speed up the car in the front and see what the car behind does. So our car, so the car in the front started accelerating, and our car start accelerating, and now it will catch up with the car in the front, and then will maintain at a safe distance of with respect to the ACC, and that is how we can control the various aspects of ACC in much like our real world scenario. So the next thing that I want to try to do is actually reduce the speed of the car in the front to 6, and our car also comes behind and starts going at roughly the same speed. And let's say I change the speed of the car in the front and accelerate it, then the other car is going to just accelerate, and then my car is actually going to accelerate and keep up with the speed of the other car. And it's back into the ACC mode following the other car. And the other factor that we allow to control is this thing called the minimum ACC distance, that roughly contributes, that says about the distance between these two cars, these two cars. And even though it says 10, and we are currently at you see 30 meters, that's because the algorithm calculated that you need at least 30 meters for this car to safely stop behind the other car. Now controlling this parameter to maybe increasing it to like maybe 50 helps increase this distance. If you can see, it will go up and will try to increase the distance, and we can just see now the car is following the other car at a much different difference. And now if I increase this one, it will try to speed up and try to catch up with the other car, and so that it can dynamically adjust the distance. In real world vehicles, we have this how closely you want this car to follow the other car, but in spite of what exact value we put over here, the algorithm still calculates its own value based on the safety, its own current speed and the safe stopping distance.